Determine the voltage of a galvanic cell made from this reaction right here at 25 degrees Celsius. The first thing we have to do in this problem is set up our half reactions, which in this case our first half reaction will be right here, so which is going to be Al 3 plus 3 electrons to Al, and then our second half reaction will be Ca 2 plus 2 electrons. When you have one of these questions, this should always be given to you, the part of the half reaction, or like, well, the half reactions, but like you have to know how to move them around so you could get like the correct half reaction. So for this one, it's gonna be negative 2.76 volts, and then for the top one is going to be E equals negative 1.66 volts. All right. Okay, so after you do that, all you have to like figure out if the half-lives are correct. So for this one, Al3 is going from Al3 to Al, so this one right here, it's correct. But like the bottom one, we can see that it starts at Ca and it goes to Ca2. So what you have to do in this one, you have to flip it around. But remember that once you flip it around, the volts will change too. So for this one, it's gonna go Ca to Ca2 plus 2E, and then 2 electrons. The E will change. So over here was negative, now it's gonna be positive 2.76 volts. So after that, once you do that, you have to identify which one's cathode and anode. So by how you do that is pretty easy. When it's anode is the one that's releasing the electrons, and then cathode is the one receiving the electrons. So on this one, we could see that Ca is the one receiving the electrons, and Al3 is the one losing the electrons. So for this one would be Ca will be anode, and then L will be cathode. So after that, once you have that, all you have to do is put it into the formula that we're gonna be using for this one is this formula right here, which is E equals E cell minus 0.0257 volts over N times the natural log of Q. Right there. The N is just like the number of electrons that in total that you're gonna be using. So how you find that is, the first thing you have to do is you're gonna have to balance the electrons on the half reactions. So that we're gonna do that, like on this one we have 2 electrons, and on the top one we have 3 electrons. So the bottom one you're gonna multiply times 3 electrons, and the top one you're gonna multiply times 2 electrons. So by the time you multiply them, you will each have 6 electrons on the bottom and the top, and after that, that's the number of electrons you're gonna use overall. So that'll be your N. So your N equals 6 electrons. And then your Q, this is something weird, but like it's always gonna be the same. So for Q at 25 degrees Celsius, it's always gonna be 1. So your Q, it's 25 degrees Celsius, so your Q will always be 1. So right here, Q equals 1 at 25 degrees Celsius. So after that, all you have to do is just plug it into your formula, which is going to be E equals your E cell, which is going to be your cathode minus your anode. So let's do it right here at the bottom. So E cell equals your cathode, which is 1.66 minus your, oh, it's negative, remember guys, it's negative 1.66. Let me continue. So it's going to be E cell equals negative 1.66 minus your anode, which is 2.76, and once you subtract it from each other, it should equal to negative 4.42 volts. So once you have your E cell, you just put it in right here. So it's going to be your E cell, which will be negative 4.42 volts right there, and then it's going to be minus your 0.0257 volts over the number of electrons, which is 6 electrons right there, and then times your Q, which is just 1. So natural log of 1, it's 0. So in natural log of 1 right here, it's 0. Once you multiply this times this, that means it's going to be 0 in total. So at the end, your answer should just be your E cell, because all of this cancels out. So your E cell will just equal, so your E will just equal negative 4.42 volts. That's it. Thank you.